Roughly 30 years ago, there was no scientific evidence for planets existing beyond our solar system. However, modern technological advancements in research have led to the discovery of more than 5,300 exoplanets, distant alien worlds poised for exploration. Initially, these findings were predominantly large gas giants, but as our detection methods have improved, we've begun to identify smaller, Earth-like planets. To date, researchers have located over 50 exoplanets that share a similar mass with Earth and more than 800 that are less than half Earth's size in radius. Few of these were known to orbit within their star's habitable zone, the region that might support life. Yet this too is changing. Our ongoing quest to find habitable planets has unveiled entire systems containing multiple worlds that could potentially support life, including one such system relatively close to us. The Milky Way itself hosts numerous such compact systems orbiting stars akin to our Sun. Typically, the planets that orbit these stars very closely are excessively hot, making them inhospitable for life. However, the dynamics change with cooler, dimmer stars where the habitable zones are notably closer. Take, for instance, Gliese 667, a triple star system situated in the Scorpius constellation, roughly 23 light-years away from Earth. This system is notable for being the first discovered where a low-mass star hosts several potentially habitable rocky planets within its Goldilocks zone. Similar to conditions seen in systems like Alpha Centauri, the trio of stars in the Gliese 667 system includes GJ 667a, a K-type main sequence star, which is the most massive in the system. This orange-red dwarf star holds about 73% of the Sun's mass, has a radius that is 76% of the Sun's, and emits only about 12% of the Sun's visual luminosity. Positioned at an average distance of 12.5 astronomical units, AU from GJ 667a is its sibling, GJ 667b, another K-type orange-red dwarf. This star carries roughly 69% of the Sun's mass and emits a mere 5% of our star's visual luminosity. Adding intrigue to the system, similar to the setup of Alpha Centauri, is the third star, Gliese 667c. This star is an M-type red dwarf, considerably smaller and colder than its companions, holding only a third of the Sun's mass and radius, and a surface temperature of 3,775 Kelvin, making it faint and cool. Surprisingly, despite its diminutive size, GJ 667c hosts a remarkably abundant planetary system. Initially, astronomers identified 3 exoplanets orbiting GJ 667c, but further analysis and observations suggest there might be as many as 6, with up to 4 potentially categorized as habitable super-Earths. A super-Earth is defined as a planet larger than Earth, yet smaller than gas giants like Jupiter and Saturn, filling a unique niche in planetary classifications. These celestial bodies could consist of solid rock, or a blend of rock and ice, potentially hosting atmospheres that might nurture various forms of life. Gliese 667cb, the planet closest to the star within its system, boasts a sweltering surface temperature of 200 degrees Celsius. This planet, the heaviest in its system with a mass around 5.5 times greater than Earth's, is likely enveloped by a thick atmosphere and orbits its star every 7 days. Situated farther from their star, 3 other planets in the Gliese 667 system exhibit masses that range from 1 to 5 times that of Earth, positioning them as promising candidates for life-supporting conditions. Notably, Gliese 667cc, which orbits nearer to the star, is perched at the inner boundary of the habitable zone. This planet's mass is roughly 3.8 times that of Earth, and its radius is 1.8 times larger, with an orbital period of just 28 Earth days. Recognized for its high Earth similarity index of 0.85, Gliese 667cc is often celebrated as the holy grail of exoplanets. Due to the low output of energy from its red dwarf star, the habitable zone around Gliese 667cc is unusually close, ranging between 0.11 AU and 0.23 AU, entirely within what would be Mercury's orbit in our solar system. To illustrate, Earth orbits the Sun from a distance of about 1 AU. If it were as close as 0.12 AU, it would be a frozen world. Orbiting its parent star at such a proximity, approximately 0.12 AU, Gliese 667cc is likely tidally locked, exposing one hemisphere to perpetual daylight and the other to eternal darkness, creating stark contrasts in temperature across the planet. With one hemisphere perpetually bathed in daylight and the other cloaked in continuous night, Gliese 667cc experiences extreme temperature variations between its two sides, likely influencing its overall climate significantly. The planet receives about 10% less visible light than Earth does from the Sun. However, because the majority of this light is in the infrared spectrum, Gliese 667cc absorbs roughly the same amount of energy as Earth, aiding in water retention and potentially fostering a climate similar to that of our home planet. The composition and thickness of the atmosphere on Gliese 667cc remain uncertain, making precise predictions about surface temperatures challenging. Should the planet boast an atmosphere akin to Earth's, it could facilitate the transfer and balancing of heat across its surface, potentially maintaining a moderate temperature of around 30 degrees Celsius on the side engulfed in darkness. Residing on Gliese 667cc would indeed offer a profoundly different living experience. The planet is bathed in a subtle reddish glow from its star, Gliese 667c. The system's other two stars, Gliese 667a and b, are situated approximately 230 astronomical units away, far beyond the distance between Pluto and the Sun. From Gliese 667cc, these stars would still be visible as bright celestial bodies during the day and would glow as luminously as the full moon at night, while our own Sun would seem like a distant dim star. A significant concern is the activity of the nearby red dwarf, Gliese 667c, which emits powerful flares and intense bursts of radiation and energetic particles, up to 1,000 times more potent than those from our Sun. Such frequent and intense stellar activity poses a considerable challenge for any potential life forms on Gliese 667cc due to its proximity to the volatile star. Moreover, the intense magnetism of the red dwarf, Gliese 667c, can lead to star spots, dark areas on the star's surface, that significantly diminish its energy output by as much as 40% for extended periods. This reduction, coupled with the star's minimal ultraviolet light emissions, presents additional challenges for the emergence of life as we understand it. Living on Gliese 667cc would starkly contrast with our experiences on Earth, not only due to environmental factors, but also because of its considerable mass. The greater mass of this exoplanet results in a stronger gravitational pull, up to 60% greater than that of Earth. As a rocky world, this increased gravitational force profoundly affects the surface conditions, influencing everything from the movement of gases in the atmosphere to the physical demands on any potential life forms. On Gliese 667cc, a person who weighs 75 kilograms on Earth would experience a weight increase to about 120 kilograms due to the stronger gravitational pull of the heavier planet. Furthermore, this increased mass allows the planet to retain a denser atmosphere, which could result in significantly higher atmospheric pressures at the surface. If Gliese 667cc possesses an atmosphere akin to Earth's, the atmospheric pressure might be only a few times greater than what we experience on our planet. However, if the atmosphere resembles that of Venus, the pressure could skyrocket to several hundred times that of Earth, mimicking the intense pressures found several kilometers beneath Earth's oceans. Despite its position within the habitable zone, the conditions on Gliese 667cc are likely quite different from those on Earth, presenting unique challenges to the possibility of life as we know it. The combination of high gravitational forces, potential for extreme atmospheric pressures, and environmental variability contribute to an alien landscape far removed from the familiar settings of our home planet. Life on Gliese 667cc would need to adapt to conditions very different from those on Earth, contending with low and variable light, high atmospheric pressure, and regular intense flares from the nearby star. Yet this doesn't rule out the possibility of life forming on such a planet. Earth's own biosphere is a testament to life's incredible ability to adapt to diverse and challenging environments. Additionally, this system includes two other planets that are nearly identical in environmental conditions to Gliese 667cc, suggesting that they too could be candidates for hosting life, demonstrating the potential ubiquity and resilience of life across different planetary environments. Gliese 667ce and Gliese 667cf are positioned further from their star compared to their sibling planet, resulting in them receiving less stellar energy. This lower energy input could render them too chilly for life as we typically understand it. However, unlike GJ 667cc, a denser atmosphere could prove advantageous for these planets by helping to retain heat and thus stabilize their climates at more habitable temperatures. Discovering 3 planets within the habitable zone of a single system is already quite rare, but identifying 4 such worlds is nearly unprecedented. Research suggests that up to 5 planets in the Gliese 667c system receive solar radiation that varies between 20% and 200% of what Earth receives from the Sun, positioning them as potential havens for life. However, other factors come into play. Scientists have delineated 2 boundaries for the habitable zone around Gliese 667c for a planet with Earth-like mass. The inner boundary ranges from 0.095 to 0.126 astronomical units (AU) from the star, while the outer boundary extends from 0.241 to 0.251 AU. These boundaries define the regions where conditions are conducive to the existence of liquid water on a planet's surface, a key criterion for habitability. Any planet orbiting within these specific distances from star C might be capable of supporting life by maintaining conditions suitable for liquid water on its surface. Being too close to the star, however, can be detrimental, as intense heat might cause surface water to vaporize and escape the atmosphere, rendering the planet inhospitable. This occurs because water vapor, a potent greenhouse gas, can significantly enhance the greenhouse effect, driving surface temperatures to extreme highs. Planets positioned at the inner edge of the habitable zone that possess greater mass are better equipped to withstand this moist greenhouse effect. Conversely, a planet situated too far from its star, such as the outermost Gliese 667g, might become encased in ice. While gases like CO2 can act as greenhouse gases to warm such a planet and stave off freezing, an excess of CO2 might counterintuitively cool the planet by reflecting solar radiation back into space, complicating the climate dynamics. Indeed, the effectiveness of CO2 in warming a planet has its limits. In a significant development in 2013, astronomers announced that the Gliese 667c system contains at least 6 planets, with the potential existence of a 7th, known as GJ 667c. This potential 7th planet has sparked considerable debate due to its potential size and characteristics. If confirmed, it could be the smallest planet discovered thus far in orbit around star C, possessing a mass at least 1.1 times that of Earth, and situated between the previously identified planets C and B. Given its mass and close proximity to the star, Planet H would likely be too hot to support life. However, planets F and E are situated comfortably within the habitable zone, enhancing their prospects for hosting life-friendly conditions. While the orbit of planet D is estimated to lie just beyond the outer edge of the habitable zone, its trajectory remains uncertain, suggesting that Gliese 667c, along with planets CF, CE, and possibly even CD, might all be capable of hosting habitable environments. The presence of such densely clustered planetary systems around M-dwarf stars like Gliese 667c underscores the vast number of similar systems likely existing throughout the galaxy. Given that M-dwarfs make up over 70% of the stars in our cosmic neighborhood, the potential for discovering numerous other habitable planets is significantly higher than previously assumed. This realization shifts the focus of astronomical research from seeking a solitary habitable planet among a group of stars to examining individual stars for multiple Earth-like candidates. With the ongoing development of more sophisticated telescopes, our capacity to explore and understand the universe continues to expand dramatically. What star system piques your curiosity next? Share your thoughts in the comments. Stay connected to be the first to learn about upcoming astronomical breakthroughs. And don't forget to hit the super thank you button if you enjoyed this update.